Welcome to everyone. I am Mahendra Weeratunga. Today I am going to continue my presentation for Combined Maths 1 2025 Part B. Okay, in my last two videos, I have completed question number 14 and question number 17. That is differentiation question and trigonometry question. Today, first I am going to look at the question number 15, that is a question for the integration. Okay, as usual, the integration question has been given with three parts, A, B, C. Let's look at the part A first. This says, let K is an element of R. The question says find integral root x dx divided by 1 minus k squared x. Usually in past question papers, we were getting this question from the partial fractions, but unfortunately this question has not been given with the partial fraction. This is a special kind of question. You need to think about some substitution. There is a way to do the partial fraction after substituting something. There are a few ways of doing the substitution. Okay, how to select the substitution? In order to select the relevant substitution, we have to look at the way of simplifying the both numerator and denominator. If I select this one, like k squared x is equal to sine squared theta. Here k is constant, but x and theta are variable. Okay, then if we select this substitution, this is simplifiable. Okay, 1 minus sine squared x will become cos squared x. Okay, let's select this one. K squared x equals sine squared theta. This is our preferred substitution. Okay. When you isolate x, s equal 1 upon k squared sine squared theta. Now let's differentiate. Differentiate both sides with respect to differentiate both sides with respect to theta. Then left side will become ds by d theta 1 upon k squared is constant. The right side will become is constant time derivative of sine squared theta. We can write it directly 2 sine theta using the chain rule times derivative of sine theta is cosine theta. That means we can separate the variable ds equal 2 upon k squared sine theta cosine theta. Now when you go back to our original integral, you can see under the integral sign dx. Now we are able to replace the term dx with this everything. Let's substitute this everything dx as well as k squared x equals sine squared theta. Integration like this, I equal instead of dx we can put 2 upon k squared. Let's keep this outside of the integral sign. Then x equal this Then square root of 1 upon k squared sine square theta I write it again by substitution. K squared is equal sine square theta. Then instead of dx you can put 2 upon k squared sine theta cos theta d theta. Okay, now I will erase this. Divided by, because this is not yet completed, I wrote the substitution for the top part only. 1 minus, instead of k squared this we can put sine square theta. Okay, what we have done so far, this is our substitution, k squared is equal sine square theta. Then isolated x, differentiate both sides by theta, then isolated ds. Put the value of ds back into here, in the original integral instead of dx. That is this one, 2 upon k square sine theta cos theta. Substitute s equals this, 1 upon k squared sine theta, 1 minus sine square theta. Let's simplify this further. 2 upon k squared the inside the bracket we have another k, 1 upon k when you remove square root you get sine theta times sine theta again, sine square theta, that is under the integral sign, cos theta d theta divided by 1 minus sine square theta, that is simplified as cos square theta. This will become 2 upon k to the power cube integral sine theta from cos theta, 1 cos theta is cancelled, sine square theta from cos theta. You can write it as separate as sine theta from cos theta. We can split this into two terms, sine theta times sine theta, then sine theta from cos theta. Still it remains sine theta in the top. Okay, now let's continue. 2 upon k cubed this one is sine theta from cos theta tan theta. Otherwise you can write like this, sine square theta. Yes, keep sine square theta as it is, that is 1 minus cos square theta. Although we separated it, this is not useful, we can go with this, sine square theta, this one, divided by cos theta d theta. Now you can separate these two terms, 1 upon cos theta, that is sec theta, cos square theta from cos theta, cos theta. Okay, let's continue our integration now. I is equal to now we can separate this integral as two integrals, sec theta d theta then minus cos theta d theta. How do you do this one? Sec theta d theta. There is a way of finding the sec theta d theta. That means you have to multiply both top and bottom by sec theta plus tan theta divided by sec theta plus tan theta. Now still I am in the first part. Minus cos theta d theta okay. How do you do this integral? By experience, you have to know the derivative of the bottom, derivative of the denominator is available, derivative of the numerator. So derivative of the denominator is equal to the numerator. That means this will become log ln absolute value sec theta plus tan theta integral of cos theta, that is sin theta. You can put the arbitrary constant outside. Now before removing theta, you can simplify this further using trigonometry. Ln 1 upon cosine theta, sin theta upon cos theta. That means 1 plus cos theta, 1 plus sin theta, upon cos theta. Okay, I will continue this question. Finally, we got I is equal to this expression. Now let's simplify this further. 2 upon k cube ln 1 plus sin theta upon 1 minus sin square theta square root. That is, instead of cos theta, I wrote square root of 1 minus sin square theta minus sin theta plus c. Now we have reached to the final step. In the final step, we can replace the sin theta with its original value. What was our substitution? K squared s is equal to sin square theta. That means sin square theta equal k squared x, sin theta, the positive square root, equal k times square root x. You can replace sin theta. You can replace all sin theta terms in this single term. Finally, I is equal to 2 upon k cube ln 1 plus k square root x divided by square root sin square theta minus sin theta, that is minus k square root plus c. Finally, you can define the definition of same, that is called arbitrary constant. Okay, this is our answer for final answer for your integral. Okay, now we have done the part A of the question number 15. Now let's go to part B. It said that show that d by dx ln 1 plus sin x 1 plus sin 2x upon cos 2x. Okay, there is an expression for that. We have to prove this is equal to 2 upon cos 2x. For theta lies between 0 and pi by 4. Okay, actually we have to prove d by ds of this one, that is the derivative of this whole expression is equal to this. Now, okay, I erase this one. Then when you start the question, you have to write this again. You have to write the left side, okay? Now let's perform our differentiation. This is ln something. We can use the chain rule first. Derivative of log mean, that is a reciprocal of this. You have to flip top and bottom. That means 1 upon this everything. Cosine 2s upon 1 plus sine 2s times multiply by then derivative of this everything. This is in the form of u by v. Then you can apply this formula v du by ds minus u du by ds upon v square. Let's start from the bottom. Cos 2x, derivative of the top, then derivative of 1 is 0, derivative of sine 2 is 2 times cos 2x minus 1 plus sine 2x times derivative of cos 2x, that is negative 2 sine 2x, everything divided by cos square 2x. Actually, simply we apply the formula to find the derivative of the ratio u by v. V, that is cos 2x. V du by ds is derivative of this whole 1 plus sine 2x, that is this term. This one is u du by dx. This multiplied by derivative of cos 2x, that is minus 2 sine 2x, divided by v square cos square 2x. Now, let's try to simplify this. Now, if you look at these two terms, you can see cos 2s in the top, cos square 2s in the bottom. Then one cos 2s term is cancelled. You can write 1 upon 1 plus sine 2x times cos 2x. What do you have here? Inside you can take 2 out from everything. Open bracket, cos square 2x. That is from here. I remove 2 from both of these terms, then cos square 2x plus sine 2x plus sine 2x times sine 2x. sine square 2x equal, what will happen? You can gather these two terms. This first term cos square 2s plus sine square 2s. Then whatever the angle we know, cos square theta plus sine square theta is equal to 1. Then this plus this become 1. Then on the top you remain with 2 times 1 plus sine 2x. In the bottom remain with 1 plus sine 2s cos 2s. Now you can cancel this whole term. Finally we remain with this one, 2 upon cos 2s. Okay, this is the answer. This is the answer we are looking for. Also, that is not the end of this question. You have to verify this restriction. Because as theta lies between 0 and pi by 2, not theta here, variable is x, 2x lies between 0 and 90. That means 2s is the acute angle. That means cos 2s is positive. Within bracket you can say cos 2s is positive as s lies between 0 and pi by 2. Because once we multiply whole liquid by 2, we are getting this one. Okay, that is the first part of part B. After that, we have been asked using integration by parts. Using integration by parts pi, this they have given a certain integral. Okay, let's write down this result again. D by dx of because we have to use this result in order to do this integral using the integration by parts. Let's start with this integral. Let's say I equal integral cos 2x times ln 1 plus sine 2x upon cos 2x. Okay, in order to perform this integral, we have to use this formula, integration by parts formula. Then one way of understanding this formula is integral of u times dv by dx equal uv minus integral v du by dx. That means you have to rearrange. You have to rearrange this given integral in this pattern. That is one function times derivative of other function. You have to figure out what u and v are. Okay. But if this is u, it is difficult to arrange this as a derivative of other one. Then let's change this and see. ln 1 plus sine 2s, let's write this first. If we see this order, you can write this again as this multiplied by this and the same as this multiplied by this. I wrote this one first. Then you have to write this term here. Now instead of this one I can write d by ds of its integral. Always any function can be written as d by derivative of its integral. D by ds of integral of cos 2s sine 2x divided by 2 dx. Now this is u. This term inside the derivative is v. Now clearly we can identify the expressions for u and v. Okay, now we are able to apply this standard formula because this is in the pattern of this one, no? uv minus v du by ds, because this integral is more simple than this. If we can perform this integral, we don't have to do this. As we cannot do this one, we rearrange like this. Definitely this should be more simple than this to evaluate. Okay, now let's continue this integration again. Okay, let's apply this formula now. U times V ln 1 plus sine 2x upon cos 2x, that is u. V mean the term inside this derivative, sine 2x divided by 2, minus under the integral v du by ds. V mean this term, sine 2x upon 2, u mean this whole expression, d by dx of, d by dx is still there, d by dx of, instead of u, you can put this value. I hope this is clear for everybody because I have explained this everything step by step. Okay, I will erase this basic formula and this one. Now we can apply actually the one we have proved before, that is a derivative. For derivative of this one at the beginning, we already got an expression. That means we don't have to do this again. This has been done for us now. Actually, that was done by ourselves, okay? Equal to, we can rearrange half sine 2x ln 1 plus sine 2x upon cos 2x minus half, we can take outside the integral, sine 2x. Now this everything will become 2 upon cos 2x dx. Okay, I wrote same thing for the plus expression. In the second part, we can cross this 2 and 2. Then rather than writing this again, actually, we can perform this integral. What is this term? When you look at the denominator, we can arrange the derivative of the denominator in the top. Derivative of cos 2s is 2 negative sine 2s. That means when you divide by 2, you have this again. In order for you to understand, I wrote one step again. Then I switch this, I send this negative sign to here. Then multiply top and bottom by 2 again. Now right away this will become ln of this. Now let's conclude our answer, okay? I wrote the first term as it is again. Then half is outside, ln cos 2x plus c. Finally, you can mention c is an arbitrary constant. Okay, we have done the second part also, part B. Part B is done. Then let's start part C. Sorry about that, these things are not erasable. Okay, I try my best to erase this, but I hope everybody can see this. Part C, that says using the formula, okay, that is very famous formula. We are getting everywhere in the same steps. These are the definite integral. 0 to a fs ds is equal to 0 to a f a minus s ds. We don't have to prove this, but that has been given. We have to show this one. Okay, I write this first. Okay. Now using this result of the definite integral, we have to show this. Although this looks like very difficult, actually, when you continue this question, you will understand that is pretty easy question. Okay, this is not difficult as this expression. How do you do this? Let's define two variables for this, two symbols for this. Let's say I equal to left side, j is equal to right side one. This is I, that is total integral in the left side. Let's say j is the total integral in the right side. Okay, now for my convenience, I erase this one. Okay. Now I define the integral in the left side as I. Okay, now let's apply this principle. This is our fx. This everything is f of x. That means total function inside the integral sign is the f of x. What is the value of a? When you compare this basic result, you can see 0 in the bottom limit of the integral, a is the upper limit of the integral, a is equal to pi by 6. Okay, that means what is this? Fs 0 to a is equal to 0 to pi by 6, as a is pi by 6. What is the difference between these two results if you look at left side and right side? In the right side, x has been replaced with a minus 6. Only thing what you need to do is, in the left side, variable x has to be replaced with a minus 6. Okay, that means in the left side integral, instead of x, you have to put a minus 6. What is a minus 6? Pi by 6 minus 6. All the x you have to replace with pi by 6 minus 6. Cosine pi by 6 minus 6 plus pi by 3 divide by sine pi by 6 minus 6 cos pi by 6 minus 6 plus pi by 3. Now you have to simplify. Actually, while you are simplifying, you must try to look at the value of j also, otherwise it will take some time. In the right side you have sin x. Okay, what is this? If you simplify this, pi by 6 plus pi by 3, that is pi by 2. Then what is this? Cos under the integral cos pi by 2 minus 6. This one sin pi by 6 minus 6. You can convert this sine into cosine. Cosine 90 minus this. This one will become cosine pi by 2 minus 6. Now we understand, we have almost reached to the end. Okay, still I am continuing I like this. Okay, now let's go back to here. I is equal to, under the integral from trigonometry you know cos 90 minus 6 sin x divided by cos 90 minus this everything, pi by 2 minus pi by 6, pi by 3, that means you are getting cos pi by 3 plus 6. Okay, cos pi by 2 minus 6 sin x. I think we can stop our process now. This is almost the value of j. This is the expression we define for j. Finally we got that I equal to j. Okay, there is a final part for the deduction. Let's write this again. I equal okay, this is I. J equal sin s divided by sin x plus cos s plus pi by 3. Now we have two expressions. One is for I, one is for j. Let's assign the equation A and B for this. Now what you have to find, what you have to deduce? We have to find actually value of I. Then let's add them together, because by looking we understand that denominators are same in the both integral. Then we can take this as a common denominator. Let's add a plus b, a and b. Then a plus b will become, in the left side we have I plus j. In the right side we have to mention this limit. Limit is common, then under the same integral limit, in the denominator we have sin s plus cos s plus pi by 3, that is in the bottom. Now you can add up two expressions in the top. Okay, what will happen? If we put a bracket for the top and bottom separately, both are same. Even under the integral sign, the two expressions in the top and bottom are same. Then simply we can cancel this, you can cross out this. Then under the integral, what do we remain? ds means 1 dx. That is x, integral of 1 is x. We can apply limit. That is 5 by 6 minus 0. What do we have left side? I plus j. But j is equal to I. We have proved that j is equal to I. The left side will become 2i. Now what is our final answer? 2i is equal to 5 by 6. I is equal to 5 over 12. Okay, these are final answers. Now we have successfully completed the question number 15 without doubt. I hope you could understand this everything. When you review this video again, actually you can slow down the video and try to understand it again. Okay, hope to see you again with the next video with another question. Thank you.